to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
A very good evening, all of you guys. Just one moment. Um, okay, chill. So kindly confirm my audio, video, everything is fine, everything is clear. So yes, very good evening. Sorry for the slight delay for 5-10 minutes. Okay, fine. Let's start the session. So am I audible to you guys? Everyone here in the live, please comment. Yes, it is clear. Fine. Thank you, everyone. So, guys, in this session, okay, I'll be discussing some tricks regarding source transformation. Definitely, many people have some concepts, some misconceptions, or something which they don't know, unexplored part in the what we call source transformation. All those things we will be discussing today. So आज का क्लास में आप लोग को क्लासेस के प्रॉब्लम्स करने के बाद आपको ये आइडिया होता है और यू विल बी गेटिंग दिस काइंड ऑफ फीलिंग दैट अरे यार ये क्वेश्चन ऐसा भी कर सकते क्या, मैं ऐसा नहीं सोचा अभी तक. ओके, दिस काइंड ऑफ फीलिंग यू विल बी गेटिंग इट. फाइन, चलो लेट्स स्टार्ट द क्वेश्चन, स्टार्ट द क्लास. Okay, so before going for the session, let me introduce myself. I hope you people know about me, even though let me introduce for the new people who are in the class. This is Bhima Sankar. I did my Mtech from IIT Kharagpur. I have 11 years of teaching experience in GATE and ESE throughout the country. I am expertised with the subjects of digital circuits, network analysis, and microprocessors, and also computer organization. In the last 10 years, I taught to several thousand students like you throughout the country. With my experience, I'll be able to guide you to reach your destination in the best possible way, undoubtedly. So, today, with my knowledge, with my experience, with the subject of network analysis, I'll be giving you some inputs for you guys. Before proceeding further, let me give you some offer of the day on Unacademy. You can save up to 35% if you take the subscription today. And today is the last date to crack this. You can use my code. You will be getting 10% discount on subscription of Unacademy Plus and Iconic. Okay, so if you take 9 months, you will be getting what we call you will be getting 2 months for free. Okay, after hike you may need to pay this much, 35,339, but now you need to pay just 28,913. The same way, if you take 12 months, you'll be getting 3 for free, and 18 pay 4, and 24 months you'll be getting 4 months for free exactly. So you'll be saving almost 35% if you take a clever decision today and take the subscription of Unacademy. Okay, so this is the code, guys. So if you have any doubts, you can contact the number of our Unacademy helpline 85858585. Okay, You will be getting the quick response and all your doubts will be cleared. And one more very important opportunity you will be having today, not only today, from Unacademy, I mean, for Unacademy subscription is if you have some difficulty with paying the money at a time, you want to pay it by EMI. If you have a credit card, it is fine. If you don't have credit card, still you need to want to pay on EMI. You can go for loan option. इसके लिए आपको ज़्यादा डिटेल्स चाहिए तो आप अगेन कॉल कर सकते हैं 85858585। इस पे आपको सारे डिटेल्स मिलेगा, ठीक है। सो 2 घंटे में आपको लोन मिलेगा, यू कैन कंटिन्यू योर स्टडीज हैप्पी, राइट। सो बाकी अनअकैडमी का आइकॉनिक सब्सक्रिप्शन, स्पेशल क्लास फीचर्स, डेली स्कॉलरशिप टेस्ट, ये सभी मैं डिस्कस करता हूँ थोड़ा सा क्लास डिस्कस करने के बाद, आई मीन थोड़ा सा क्लास आगे जाने के बाद, ओके, वी कैन डिस्कस दिस फर्दर, राइट। सो यू विल बी वेटिंग फॉर द ट्रिक्स। मुझको पता है आप लोग को शॉर्टकट्स ट्रिक्स है, तो यू आर मोर इंटरेस्टेड इन दैट, आई नो इट। बट एज माई रेस्पॉन्सिबिलिटी, आई विल बी गिविंग यू सम बेसिक्स फर्स्ट। सो मैं तो थोड़ा सा बेसिक्स देना चाहिए। वो बेसिक्स कुछ नहीं, दैट इज सोर्स ट्रांसफॉर्मेशन का बेसिक्स, ठीक है। यू माइट बी नोइंग इट ऑलरेडी, बट स्टिल लेट्स जस्ट फॉर कंटिन्यूटी लेट मी गिव यू द बेसिक्स। Right. So you might be knowing it, the source transformation ka basic kya, it is used to convert the practical sources. It cannot be applied for ideal sources. It can be used to convert the ideal or practical voltage source into its equivalent practical current source. Okay. So this is the basic. If you have a voltage source Vs in series with a resistance Rs, I can replace this with an equivalent. I know many people knows these basics, but just give me 5 to 10 minutes to cover the basics. Then we will jump into the tricks. ठीक है, right? इसको ऐसा convert कर सकते हैं and vice versa. This is what given by source transformation. ठीक है, right? Here मैं तो एक load connect करना चाहिए, a load resistance RL. Here एक load resistance RL connect करना चाहिए। दोनों केस में my what we call दोनों इक्वलेंट होना चाहिए, तो ठीक है। हाय राजेंद्र, ओके, थैंक यू CSIT एंड एवरीबॉडी, ओके। चलो, दोनों केस में मेरे को करंट सेम चाहिए भाई, मेरा करंट दोनों केस में सेम होना चाहिए। तो क्या करना, I need my current to be same in both the cases. Then what I need to do exactly? Let us see. In the first case, if they are equivalent, मेरा load current should be same in both the cases. So it will be Vs by Rs plus RL. ठीक है। इस केस में करंट कितना होता है सर? टोटल करंट इनटू ऑपोजिट रेजिस्टेंस बाय टोटल रेजिस्टेंस। So when will I say both the networks are equal and you can replace voltage source with a current source with a voltage source? ऐसा बोलना चाहिए, मेरे पास एक वोल्टेज सोर्स है तो इसको मैं रिप्लेस कर सकते हैं करंट सोर्स से। सो कब बोल सकते हैं हमने वोल्टेज सोर्स को करंट सोर्स से रिप्लेस कर सकते हैं, और वाइस वर्सा इज दोनों का लोड करंट सेम होना चाहिए। द लोड करंट इन बोथ द नेटवर्क्स मस्ट बी सेम, ठीक है। सो इस केस में, ओके, प्लीज लिसन केयरफुली, ये दोनों इक्वेट किया तो इफ यू इक्वेट बोथ ऑफ देम, माय डिनोमिनेटर इज ऑलरेडी सेम, दोनों पे डिनोमिनेटर तो सेम है। अगर न्यूमरेटर सेम किया तो दोनों केसेस में करंट सेम होता है भाई। इफ यू मेक योर न्यूमरेटर सेम इन बोथ द केसेस, then you will be getting the current will be same in both the cases. So Vs equal to Is Rs, or what is the required condition? Is equal to Vs by Rs. Without any confusion, we can say like this: if you have a Vs and Rs, what is its source transformation? Here Vs by Rs parallel with Rs. ठीक है. Similarly, if you have Is parallel with Rs, what is the equivalent? ISRS in series with Rs. ठीक है. करंट सोर्स को हम वोल्टेज सोर्स से रिप्लेस कर सकते हैं विथ वोल्टेज इक्वल टू IR or I equal to V by R. Arrow direction should match to negative to positive. These are the things basic of the source transformation. ठीक है. ये तो बहुत बेसिक है सोर्स ट्रांसफॉर्मेशन के बारे में, बट फिर ये सभी लोग को मैक्सिमम पीपल नोस अबाउट इट. ठीक है. नो प्रॉब्लम. लिसन हियर. So let me go further. Here, for example, you have a voltage source Vs, resistance Rs. मैं इसको replace किया Vs by Rs parallel with Rs. I say both are same. Listen carefully. The important part here. अगर मैंने इसको शॉर्ट किया तो इस पे करंट कितना चलेगा भाई? करंट कितना चलेगा? Vs by Rs. अगर इसको शॉर्ट किया तो इसमें कितना करंट चलेगा? How much current I will be getting here? When you have a short circuit, no current flows here. Total current will be flowing here. दोनों केस में मेरा लोड करंट इज सेम. ठीक है. ठीक है. But very important, this is what you need to know is इस पे करंट कितना जा रहा है भाई? RS पे I. ओके. बट इस पे करंट कितना जा रहा है भाई? 0. नॉट सेम ना. दे आर नॉट सेम. सो मेरा रेजिस्टर पे करंट तो आई जा रहा है, सो दूसरा वाला में मेरा करंट तो 0 जा रहा है, सो बोथ आर नॉट सेम. सो हियर द पावर कंज्यूम्ड बाय दिस रेजिस्टर इज I square into Rs. What is the power consumed by this resistor? 0 square into Rs. 0. So दोनों सेम है क्या? नहीं है भाई. दोनों सेम है क्या? नहीं है. Listen here carefully. Listen here carefully. Okay, understand. Carefully listen. I can say source transformation is applicable externally. That is, load current will be same in both the networks. But internally they may or may not be same. जैसा Tilligan's theorem में you want to know whether it is delivering or absorbing वाला cases. In those cases, source transformation is not applicable. For example, let me take. What about dependent source, sir? Can we apply source transformation to the dependent source? Listen. So this is I1. Here, whenever this I1 is outside this loop, many people think that dependent sources में source transformation is not applicable. 100% it is applicable, provided here the difference, the source transformation में this is depending on I1. Okay, variable is I1. As long as that I1 is not disturbed, you can apply it. So इसमें I1 by 4 into 20 equal to how much? You can replace with 5I1 series with 20. Okay. This is 10. This is 10 and I1. Just a minute. What is I1 in this case, sir? Okay. If this current is I1, 1 minute. Let's take this as I1 for just better results के लिए. Okay, so just for giving you some positive results, I want to give you. Fine. So here, if you solve this question, what is this? If it is I1 by 4, this is 3I1 by 4. Okay, so this will be how much? Again, I1 by 4 and 3I1 by 4. This is I1. This will be 10I1. Okay, and this will be 20 into 3. 60 by 4 is 15I1. So by KVL, right? So positive to negative minus 15I1, positive to negative minus 10I1, positive to negative minus 10 equal to 0, minus 25I1 equal to 10. आपका I1 कितना? minus 10 by 25. I'll use it later, leave it. ठीक है, इस केस में I1 कितना होता है सर? Current enters from positive leads to negative. Apply the KVL. Negative to positive 5I1 minus 20I1 minus 10I1 minus 10 equal to 0. So 10 equal to ये 5 जाएगा minus 25I1. आपको दोनों केस में सेम आंसर आ रहा है? Yes sir. After source transformation and before source transformation के बाद भी, इसके पहले भी मेरा आंसर तो सेम, दोनों केसेस में मेरा I1 तो सेम है. सर क्या डिफरेंट है सर इसमें? लिसन केयरफुली, ये तो इंपॉर्टेंट ऑब्जर्वेशन होता है. लिसन हियर, व्हाट इज द वैल्यू ऑफ I1? ओके, I1 by 4 equal to minus 10 by 25 by 4. That will give you minus 10 by 100. So minus 0.1. Okay, so here what is the drop? 15 I1. 15 means 150 minus 150 by 25. Okay, because it is 15 I1 na, I kept it here, right? So I1 is equal to how much? 10 by L. So 15 into I1 is this one. So here you observe, see here, the original current direction is reverse and original polarity is also reverse. But okay, if you take the original polarity is like this, 150 by 25, and the original current is in this direction 0.1. This fellow is absorbing or delivering? Please comment. Okay, please comment. Here, this fellow is delivering or absorbing? Comment. Okay, please comment. Thank you, Rajender. Thank you very much. Yeah, please comment here. The first dependent source, very good Shaumik, ये तो absorb कर रहा है. In the first dependent source तो absorb कर रहा है, ठीक है भाई. But the second case में dependent source क्या कर रहा है sir? Here it is minus 10 by 25. But here what it is doing? Minus 5 na, 50 by 25. But the arrow direction is negative to positive. Negative current, negative voltage. ठीक है, you can change it also, no problem. This will be 10 by 25. Okay, reverse polarity पे you will be getting 50 by 25. Okay, you understand, because I1 is negative, reverse polarity. But arrow direction you can see is negative to positive, means this is delivering the power. Or simply you can say like this, if this is I1, what is the resistance of the dependent source? Arrow direction negative to positive is minus 5I1 by I1, minus 5. Okay, minus 5 plus 20 may be 15, leave it. Here also, what is the resistance of the dependent source? I1 by 4 is the current, voltage is 15 I1. Okay, arrow direction is positive to negative, so plus 15 I1 by 4, it will give you 60. 60 parallel with 20, 15. Here minus 5 plus 20 will give me 15. Externally this part is equal to 15 ohms. This part is equal to 15 ohms, no doubt in it. ठीक है, ये part जो है ना ये तो 15 ohms here, ये part जो है ना ये तो 15 ohms here, no doubt. But internally if you see, this fellow is delivering, this fellow is absorbing, right? Internally, the relations are not same with the source transformation. This point you should know. So when you need an internal response of this, you may not be able to get the proper value by using the source transformation. Okay. So this, if you have in mind, one more point I'll give, then I will give you the tricks. अभी तक मैं एक trick भी नहीं दिया, basic facts दे रहा हूँ, basic facts दे रहा हूँ, एक trick भी नहीं दिया. I will give you the best possible trick. Just wait for a few minutes. Don't miss it. Right. Listen, one more important equivalent circuit is, you can say shortcut, or it is a most common. Whenever you have a voltage source in series with a resistor, parallel with another resistor, what is the equivalent of this is by using repeated source transformation. I'm not going through the proof. You can blindly replace this with VR2 by R1 plus R2 series with R1 R2 by R1 plus R2 हो गया. Wait, if R1 equal to R2 equal to R, इस केस में it will become V by 2 in series with R by 2. I can prove this also. चाहिए तो आप source transformation apply किया तो ये V by R1 होता है, right? R1 होता है, R2 होता है, R1 R2 पैरेलल है ना. थोड़ा सा स्पीड चल रहा हूँ क्योंकि ये तो रेगुलर क्लास तो नहीं है ना. रेगुलर क्लास में आई गो लिटिल स्लो. सो व्हाट इज द इक्विवेलेंट हियर? This R1 cancels. Right. So this is the final conclusion here. ठीक है. चलो. Okay, listen carefully. Fine, this is the equivalent of this. अभी तक मैं केवल facts दिया. Now we are entering into the tricks or problems, whatever you want. If you are ready, if you have the patience to listen up to this point. Many people ऐसा है, देखते 2 मिनट का क्लास, डिसाइड करते अरे यार ये सभी मुझे को पता है ऑलरेडी. ऐसा मत सोचना, ठीक है? There are always, if whoever waits with patience up to this much amount of time, now you people are going to learn many new things. Listen carefully. ठीक है? चलो. So the first question for you, okay. So first question for you, to find V comma I, can we apply source transformation? Okay. Can we apply the source transformation while finding V and I? Otherwise, only first you take I. To find I, can we apply source transformation to 10 volts source? You please comment yes or no. I need current this one. Can I apply source transformation and do this problem? Yes or no? Right. Please continue, Shubham. This is the important point. Yes, tell me. No, not for 1 ampere source. I am saying about for I. For 10-volt source, can I do it or not? Okay, everybody. No, not for 1 ampere source. Again, I'm saying for finding current in the this current, can I apply source transformation to this 10 and 2? Yes or no? For 1 and 2, you can apply it, not for this 10 and 2. Okay. So let me find whether I can do it or not. Let's take this node voltage as V, this current as I. Okay. So what is the equation? V minus 10 by 2 plus V by 2 plus 1 equal to 0. Simple node analysis. V minus 10 plus V plus 2 ones 2 equal to 0. 2V equal to 8. आपका V कितना आया? 4. Right. Okay. Now what is I? 10 minus V by 2. 10 minus 4 by 2. 6 by 2. 3 amperes. ठीक है. Now let me show you different cases. 10 by 2 is 5 and this current will be 2 if you take this as your I. Okay. And now 2 and 1. This I will be equal to 5, which is a wrong answer. Where original I kitna 3. Once you apply source transformation, that will give you 5 and 2, which will give me wrong answer. Similarly, you can do like this, as some people told me. First source we keep as it is. For the second source, you can apply source transformation. 2 and 1 will give you, it will give you 2 and 1. And current I will be 10, sorry, 2 ones kitna 2. 10 minus of minus plus 2 by 4, 12 by 4, 3. Actually, this everybody knows, this also many people, at least most of you knows. There is no trick in this part, Now, I am going to solve this question. In exam, if they ask you, can I apply source transformation, means you may say no, but okay, fine. You want to solve this question by using source transformation only. Is it possible after doing this or not? Now let me show you the trick. Listen here. This is a 10 volt source. ये I मुझको चाहिए. Okay, this is my network. ठीक है, चलो. Now I apply the source transformation. Okay, this will be 5. This will be 2. Okay, here it will be 2. It will be 1. ठीक है भाई, ठीक है. Now ध्यान से सुनो भाई, ये करंट तो I है, ठीक है. ये करंट भी I है ना. ये करंट भी I है ना. So मैं ये लेता हूं 2 के बाद, because your transformation is happening here. Transformation is happening here 2 के बाद. It remains same. So यही पे मैं I लेता हूं. ठीक है. So now here listen carefully. Okay, so now listen. Entering current is -5, V by 2, V by 2 plus 1 equal to 0. So -10 नहीं है तो -5 plus V plus 1 equal to 0. मेरा V कितना आया 4. So this is 4, 4 by 2 is 2. This is 4, 4 by 2 is 2. 5 is coming here, 2 is leaving. Then what is this current? Comment your answer. This I will be equal to 5 minus 2, 3. This is right answer. Now you understand the logic. You should keep the current in the branch which is undisturbed. Then you will be able to solve the question by using the source transformation. So generally it is not applicable, we feel, but still we can do it by using some small trick. This is the starting part of the class. Now we do this kind of many questions like this. First thing is clear to everybody, please comment. Yes, definitely. With okay, I'll show you many circuits now. This is the beginning. Okay. So first tell me guys, is it clear? ये clear है भाई? ये क्वेश्चन तो मैं डायरेक्टली ऐसा किया तो ये cannot apply the source transformation. What I did is with clever, instead of entering current of 2 ampere, I took it as a leaving current of 2 ampere. So इस पार्ट में हमने source transformation अप्लाई किया तो भी कोई दिक्कत ही नहीं है. External current will remain the same. ठीक है? By using this concept, I have applied the source transformation and able to solve the problem. Okay, right. So very good, fine. Everybody understand the first part of this? Okay, now let's move for the next. Again, I want to test you. Say for example, one simple example there. See the application of this. Say I want to find I here. Okay, I want to find I here. मेरे को I चाहिए यहीं पे. Normally solve कर सकते हैं by taking the node equation v minus 30 by 2 v by 2 v by 2 find the v, then I equal to 30 minus v by 2 उतना करना चाहिए. But now हमारा trick देखो. To take this as I, this will be 30 by 2, 15 parallel with 2, keep this as I, and the remaining network you copy as it is. Now you understand the concept. Total current here will be 15, which will divide into 5, 5, 5. So what is your I is 10. You should not take 15, but you can take I 10 directly, you can say. Right? It will take one step to get your answer. Normally if you want to do, just you can do it. V minus 30 by 2, V by 2, V by 2 equal to 0. V minus 30 plus V equal to 0. V equal to 30 and V equal to 10. इसके बाद I equal to 30 minus V by 2. That will give you 30 minus 10 by 2. 20 by 2 will give you 10. इतना करना चाहिए, बट हमारा ट्रिक से एक स्टेप में आपको आंसर मिल रहा है. जस्ट अप्लाई सोर्स ट्रांसफॉर्मेशन, move this I to this point, you will be able to do it. Okay, so let's do one more question now. वोल्टेज सोर्स के लिए मैं तो किया, and you understand you can do it. Can we find I by source transformation. Okay, now you think in this way and try to solve it. I want to find this I. Can I apply source transformation for 5 and 2? That is 5 ampere and 2 ohms को source transformation apply करके I निकल सकते नहीं निकल सकते बोल दो. Yeah, I will give you what we call Shaumik all possible conditions. Don't worry. You will not be left over from the class with a single doubt in your mind. ठीक है? सारे exam. I will finally give you the conclusion, not to remember the things, to understand the concept. Then you will not have any doubt whether I can apply here or not. Because मैं तो conceptually जा रहा हूँ. थोड़ा सा wait करो end तक. ठीक है? आप लोग बताओ इसका आंसर. Can we try this question by source transformation? भार्गव ने बोला नो. बाकी लोग भी बताओ आपका आंसर. I can do it or I cannot do it by source transformation. Don't think because पिछले वाला क्वेश्चन तो किया सर ये क्वेश्चन भी पॉसिबल है, ऐसा मत सोचना. ठीक है? वहीं पे रेजिस्टर में करंट तो सेम, हियर इट मे नॉट बी सेम. सो प्लीज थिंक एंड टेल मी. वेरी गुड, वेरी गुड. हु इज दैट? एक्सक्यूज मी. कुणाल. सही है भाई. चलो भाई, ये करंट आपने सोर्स ट्रांसफॉर्मेशन किया तो डिस्टर्ब होता है भाई. ठीक है, बट दिस करंट इज 5. व्हाट इज दिस करंट? 5 minus I. Yes, this is important for me. Okay, this is important for me. I'll keep after source transformation. This external current remains the same. So now what I will do? 5 twos here 2. This will be 10. Okay, and the remaining part will be copied as it is. Understand? So this current is 5 by I. So 10 by 2 plus 1 plus 1. What is this? 2.5. So 5 minus I equal to 2.5. I equal to 5 minus 2.5. चाहिए तो आप लोग इसमें भी कैलकुलेट कर सकते हैं करंट डिवीजन प्रिंसिपल से. 5 इंटू ऑपोजिट बाई टोटल. ये तो आसान है बट you got the same answer or not. So here you understand now. Maybe I disturb हो सकते हैं. External branch का current is not disturbed. Take that and find I. There also you can apply source transformation. Actually, if people ask you whether I can apply, means you can say no. But can you do it with source transformation? Yes. Right. Now whoever in the class, now you understand everybody the trick, the concept behind this. ठीक है, चलो let's move further for one more example. Okay, so let me show you one more thing. For example, the same question. Okay, just same question I'm taking for your understanding. I want to just show you the n number of ways you can solve a single problem. Okay, okay, without this source transformation, I want to apply something else and I want to find the answer. What is this drop here? 2i. Yes or no? Fine, leave it. So here, what is the source transformation of this? Can I say this is 5? Okay, and 2 parallel with 2. And the drop here is 2i. It remains same na, just you take this 2 parallel with 2. What is the value? 2 parallel with 2 kitna? 1. Okay, so this will be 1. Okay, now listen carefully. So you can take the source transformation, 1 will come here, 5 volt will come here, okay, and this drop will remain 2i. Because it is open circuited, no current will flow. 2i equal to 5, I कितना होता है सर 2.5. आंसर तो मिला ना. So after source transformation also, whichever part is undisturbed, इसको लेके you can find the solution. नहीं है तो आप ऐसा भी कर सकते हैं. Listen here. Just for your better understanding, this is I. Okay, if it is 2I, because this 2I is divided among two resistors which are in series, can I say this is I? Can I say this is I? Okay, so you can apply source transformation to this part also. This will be 2, 10, and 1, and 1, and this is your I. What is this drop? 10 by 4, 2.5. I want to say you can make any magic to the network. Keep at least one branch in your hand which is undisturbed. उस branch का relation, if you know it, you can find any other variable even that branch is disturbed. Now you understand? Very good, very good. Wait. Let's take one source transformation. So what we call this one. Let's take one dependent source now. What is the current I? Okay, आपको current I चाहिए. Okay, listen carefully. Okay, I नहीं, I1. By using source transformation, try to find I1. Okay, find I1. I need to apply source transformation here. Two source transformations to be applied. I want both of them to be applied with source transformation. Still, I need to find the I1. Let's see how to do it. You can do by n number of ways. Okay. So what is the drop here? 5I1. This is also 5I1. This will be 5 by 2I1. Okay. This is one method. Now listen carefully. ये 10 एम्पियर है तो ये I1 मुझको चाहिए, but I want to disturb this branch. You know this current. What is this current? 10 minus I1. ठीक है? 10 minus I1. Now see here, you just neglect this resistor which is in series with the current source. ठीक है? So now what happens? I1 by 4 parallel with 2. I1 by 4 parallel with 2 is I1 by 2 in series with 2. Okay, similarly here 10 parallel with 5 is 5 and 50. Okay, and what about this current? 10 minus I1. Okay, this current should be kept as it is. Now you can find the answer easily. 50 minus I1 by 2 by 7 equal to 10 minus I1. Okay, so 50 minus 0.5 I1 equal to 70 minus 7 I1. Okay, you take this other side. Got it? So फाइनल कंक्लूजन तो ये है, कोई भी सर्क्यूट ले लो किसी भी नेटवर्क पे, हैप्पीली यू कैन अप्लाई सोर्स ट्रांसफॉर्मेशन. बट if your branch current is getting disturbed, any variable is getting disturbed internally because of the source transformation, take the external relation of that variable, it remains as it is. This is the conclusion of today's class. Okay, ये वाला part. So generally if before this class if I ask you, can I apply source transformation and do this question to find I1, means everybody says no, sir. I know it. Many people, at least 90% of the class will say, no, sir, we cannot apply. But now, any question comes, okay, if it makes your analysis easy, yes, you can apply, even there is a variable there, no problem. I will apply source transformation and do it by keeping that variable relation constant. Okay, you should check the thing, the relation which is undisturbed because of the source transformation. That you keep it. Remaining part, whatever you do, it doesn't matter. Here I neglected this resistor because it is in series with the current source. Okay. Everybody understand the total whatever the part I have given to you. Okay. Starting में केवल basics दिया. This is the very important trick. So by using this, any network, any problem is given, you can happily apply the source transformation and solve it easily. Even the variable is getting disturbed also. Normally, if the variable is getting disturbed, we don't apply source transformation, is what you study. Even I also teach conventionally that. But if you want to crack it, even the variable is disturbed, you want to apply the source transformation, you can go by these kind of methods. Okay, fine, right? Chalo. Then I don't want to waste your time further. I hope you understand the things. You have any queries now regarding any kind of question you ask? Okay. Do you enjoy the class? At least by this, you spend around 50 minutes of time with me. In this 50 minutes, you are able to learn one new point or not. Please comment. I will be very happy to see your comments. Okay. Preeti, way to revise network in HRS. What is that? Like you want to revise in less number of hours? I already told you want to revise in the less number of hours. I started one series. I don't know whether I will continue or not. In the special classes, daily I'm taking network in 5 hours. That is every day 1 hour. I'm revising one topic. If you want, you can attend that. Okay. Today I took 1 hour and I revised the basics. Okay. So fine guys, please comment. We can end the session for today and we can move, and you have your own works and I have my own works. We can continue. Tomorrow, I want to solve the problems of transients with the second order systems. Many people will face difficulties with the second order systems of the transient. I don't have any tricks regarding that, but I will give you the solid conventional way, or what we call proper way with basics to solve the second order systems, we will be discussing tomorrow in the class. Okay, tomorrow class may I'll be solving the problems of second order systems. Don't miss that. Okay, fine. So then let's. So again, I'm saying that today is the last day for this deal, guys. Upload, use the code Shankar10 if you like my classes, or even you or your friend, anybody want to join. So you want to beat the price hike and get the extra months of the subscription also. Subscribe to an academy using the code Shankar10 today itself. Okay. Right. So if you take iconic subscription, आपको one-to-one mentorship मिलेगा. Okay, you can schedule that session according to your convenience. Exam का guidance मिलेगा, and you will be getting progress report and regarding your preparation. So attend the an academy का special classes. मेरा profile is available in this video description. आप इसको follow करो. You follow my profile on an academy app, then you can get the access of all my free classes. Okay. So, guys, daily scholarship of an academy happens. You can join that if you get 50% scholarship. If you get rank one, you get 50% off, and based on your ranking, you will be getting the scholarship up to 10%, 15, or what we call 30. Okay, this is the PYQ series from an academy. You can practice with that. And community feature is now available with the Android app also. So you can go to an academy homepage, click on community, discover. You can follow your favorite educators. You'll be getting all these updates for you. Okay. So these are the batches going on right now with an academy plus subscriber students. Control system has started in this week by Aditya sir. Okay, and these are our toppers this year from GATE and ESE. So you can see these are the features of an academy subscription, guys. आपको टॉप एडुकेटर का क्लासेस चाहिए, डाउट सॉल्विंग सेशंस चाहिए, डेडिकेटेड डाउट सॉल्विंग सेशंस with interactive classes and what we call online notes. You can go for an academy plus subscription. आपको what we call one-to-one mentorship चाहिए, and you need physical notes also where you can carry the notes and study, then you can go for iconic subscription. ठीक है? Thank you. That's all from my side for today. I hope you enjoyed the class. If you have enjoyed the class and learned something new from this particular class, I want you people to share your experience in the video links available. That is, wherever in our groups you saw the link and join this class, उस link पे reply दे दो, how is your class, so that others can understand and they can also learn from these free initiatives. Thank you very much, guys. Okay, Kunal, yeah, please tell me why that 2 ohm resistor is neglected. Any element which is in series with the current source parallel with the voltage source will be neglected in the analysis. When to neglect, when not to neglect, मैं तो comprehensive course में already discuss किया. Please go through that in the equivalent circuits topic. Any other question, any other query? Okay, thank you very much, guys. See you all. Good night. See you tomorrow at 9 p.m. Bye bye.